very pleasant morning. So in this session we are going to discuss about introduction to 8085 architecture. So what is this 8085 architecture? Actually it is a microprocessor. We call that microprocessor as an 8-bit microprocessor. So we have three main sets in this. We have input device and we have a microprocessor unit and we have a memory unit separately. Then comes your output device. So this is the basic outlook of a processor. So input device, in the microprocessor we have ALU, control unit and register array. So ALU, that is arithmetic and logic unit, it performs arithmetic and logical operations. Then we have the control unit, then we have the register array. So memory unit is separately attached to the processor. So here next we are going to discuss about the architecture. This is the basic architecture of 8085. So in architecture of 8085 we have various blocks in this. So very important one is the accumulator. Accumulator is the A register. So next we have various registers, flag registers. So the purpose of the flag register, it will indicate it will just indicate the status of the result, whether we have any carry or zero or like that. Everything is indicated in the flag register. Totally we have 5 flags in 8085. Sign flag, zero flag, parity, auxiliary carry and tally flag. So these are the 5 flags and flag register is a 8-bit register. Now ALU already we have discussed, it is arithmetic logic unit. It performs arithmetic and logical operations, all the arithmetic and logical operations. Next thing we have various registers of, other than accumulator we have various registers as in pair, BC pair, DE pair and HL pair. So BC pair and DE pair are register pairs and HL comes under your memory register, and we have stack pointer. So stack pointer is, it will point to the address of the next instruction to be executed. That is your stack pointer. Next we have various temporary registers. When we come to the address and data bus, we have 8 data bus and 16 address lines. What do you mean by buses? Bus is actually a group of wires. It is used for transfer of the informations. So we can classify the buses into 3 types: address bus, data bus and control bus. So address bus means it will transfer the address, data bus it will transfer the data, and control bus it will transfer the control signals. So we have various signals here: ready signal, ready, read, write, ALU. All are control signals of 8085. S0, S1, IO/MR are status signal of 8085. Hold HLDA signal comes under your DMA. Reset and reset comes under your reset signal. So here ready signal we have, that is the processor is ready to transmit or receive the data. Further we are giving this ready signal. Then we have read signal. Read signal is used to read the data. Write signal is used to write the data or information into the external device or processors. Okay. Next we have the ALE. ALE expansion, that is ALU is different from ALE. ALE is address latch enable. So what is the purpose of address latch enable? It will demultiplex the address and data. If you see here, address line is 80 to 87. We are having both address and data line together. 80 to 87 means it has both address and data line together. And A8 to A15 has separate address line. So if it is having a separate address line, we can transfer the address. But in the case of 80 to 87, we have to know whether we have to transmit address or data, because we have both address as well as data lines together. For that we are using this ALE. When ALE, address latch enable is equal to 1 means it will transmit the address. If ALE is equal to 0 means it will transmit the data. For that we are using this ALE signal. S0, S1 and IO/MR. IO means input output, M stands for memory. This combination of S0, S1 and IO/MR will decide the machine cycle, what type of machine cycle to be used in the system. Next we have hold and HLDA. Both hold and HLDA comes under DMA, direct memory access. So direct memory access has hold and HLDA. So hold signal, what is the meaning is, the external devices can use the processor's memory. All these things can be direct memory. So external devices can use the memory of the processors. Okay. Let's reset in and reset out. It will come to the initial question. So that is the purpose of this. Next we have interrupts. Interrupts, there are various types of interrupts. Trap, RST 7.5, RST 6.5, RST 5.5, INTR, and acknowledge of that is INTA. So these are the various interrupts. Trap is having the highest priority, INTR is having the lowest priority. Next is serial input output, we have 2 single, SID, SOD. So these are all the various blocks we have. So here we are having the pin diagram. So this is the pin diagram of 8085, 40 pin IC, the same whatever signals are discussed here, the same following signals are available in the form of pins. If it is an input signal, the arrow mark will be inside. If it is an output signal, the arrow marks will be outside. So these are all the various signals. These signals are arranged in the pin. So 20, we are totally 40. It is a 40 pin IC. So all the signals what you have referred in the block diagram, the same thing will be coming in the pin diagram, but it will be represented in the form of pins. Thank you.